Good morning once again, beta.
Good morning, ma'am.
So far, we had finished with the clinical thermometer and we are starting with the laboratory thermometer. I hope you know right now the difference between both the thermometers, beta. You are aware of the difference between both the thermometers? Yes, student, can you hear me?
Yes, ma'am.
Yes? Okay. So, what the clinical thermometer does, beta? It takes the temperature of human body, right, beta? And what is laboratory thermometer doing? It is taking the temperature of liquid and solids. Is it clear? Hello?
Yes,
Is it
ma'am.
clear? Yes?
Yes.
So start reading regarding
Ma'am, can I
laboratory.
read? Aisha.
Aisha. Okay, read. But you have to read properly,
Yes,
please.
ma'am. Yes, ma'am. Laboratory thermometer. A laboratory thermometer has a long, narrow glass tube. It has a bulb at one end containing mercury. It has a scale marked in
Degree
degree Celsius, the range
in degree
range
C.
of a
Aisha,
yes, and
it is
degree
in
C
degree C. Then you will say degree
in
Celsius. Okay?
yes, ma'am. In degree Celsius, the range of a laboratory thermometer is generally from 10 minus
No.
10 degrees C to 110 degrees C.
Well done. You need practice again with Aisha. Keep practicing how to read. Okay? So what is a laboratory thermometer? It is a narrow, but it's a long. It's longer than clinical thermometer. Again, as in clinical thermometer, we had a bulb at one end. Similarly, we are having the bulb at one end of the laboratory thermometer, and it has got mercury. So both the thermometer has got mercury. Marking is in degrees Celsius, and the range is minus 10 to 110 degrees Celsius. This is what you have to learn. This is how it looks like. See, you see this thermometer? You can see this thermometer. This is the bulb, which has got mercury. Okay, Vita? Hello.
Yes, ma'am.
Yes. You can see the bulb, which has mercury.
Yes.
You see now? You see this? This is the bulb. About to throw it. Read again. I'm taking different slides on the same topic so that it gets revised in the PPT itself. You understand? You don't have to
Yes.
revise it differently. Right now in the class itself, you revise the topics. That's why I'm taking different slides. Okay, start reading it.
Ma'am, can I continue?
No, beta, someone else. Each slide should be taken up by different people.
Ma'am, we have to read it.
Yes, beta, you have to read it.
Can I read Insia Fatima?
Okay, beta. And the one who reads nicely, I will ask that girl or the person to continue. Is it clear?
Okay,
And if
ma'am.
I don't ask you to continue, you should understand that you need to practice. Okay? Start
The
reading it.
laboratory thermometer is used to find out the temperature of the other objects such as water rather than human body temperature.
So this laboratory thermometer is being used for everything except human body. Is it clear?
Yes.
You
Yes,
can
ma'am.
take, you can use this thermometer for each and everything except human body. Is it clear? You can take temperature of solid, you can take temperature of liquid, you can take the temperature of any object, but not human body. Am I clear?
Yes, ma'am.
Yes.
It can measure the temperature from minus 10 degrees Celsius to 110 degrees Celsius.
You understood? So these are the things that you have to remember. The difference between the clinical thermometer and the laboratory thermometer. Is it clear? Is it clear, better?
Yes, ma'am.
This is how it looks like. The thermometer, better. This is how it looks like. So you can see over here that here it is degree Celsius and here it is degree Fahrenheit. Just want to show you again. There are two scales. This is degree Celsius and this is degree Fahrenheit. You understand? So on one side it is Fahrenheit and on this side it is Celsius. So you can take in both the scales. Now how do you do it? How do you measure the temperature? Taking the laboratory thermometer. Let's do. Read later. So you can continue.
Yes, ma'am. Measuring temperature with a laboratory thermometer. Take some tap water in a beaker. Dip the thermometer in the water so that the bulb of the thermometer does not touch the bottom of the sides of the beaker. Hold the thermometer vertically. The mercury becomes steady.
No, no, the mercury level rises.
Vertically, the mercury level rises. Wait till the level of mercury becomes steady.
Steady.
Not note the level of mercury. This will be the temperature of the water.
Did you understand? Did you understand,
Yes,
Vita? Now, instead of beaker, it is a conical flask is shown. What is this called as? Flask. And the beaker looks like this. This looks like beaker. Is it clear? This is the beaker. You understand better? This is the beaker. Okay. But instead, we have taken flask. So you can see the laboratory thermometer still here. Can you see this? It is still here. It is not here. It's not touching the bottom, but it is in between. Okay. So this laboratory thermometer should not touch the sides, should not touch the bottom. Is it clear? Is it clear?
yes, ma'am.
So this thermometer somewhere should be just connected to the liquid. It should not touch the sides of the container, not the bottom of the container. It should touch only the liquid. And then you can know the temperature, and that will be the temperature of that particular liquid. Is it clear? Girls, is it clear?
Yes, ma'am.
That's how you take the help of laboratory thermometer to take the temperature of a liquid or a solid. You want to ask me any question? Do you want to ask me anything, Vita?
No, ma'am.
No, ma'am.
Now, yes, we will read.
Ma'am, can I read Dhulia Fatima?
Okay, Vita. Continue. Fatima. Learn from others how they are reading. If I am asking the person to continue, you should understand that next time I should tell you to continue. Do you understand? So
Okay,
from
ma'am.
each of you, from your colleagues, you should learn why do I ask them to continue. So you practice in such a manner that you become perfect. Okay?
Ma'am, can I read Insia Fatima? Ma'am, can I
Now,
read Dhulia Fatima?
You have already read two slides, I think so.
Ma'am, I am Ravjan Insia Fatima. Rajbari Insia Fatima has read.
Okay. There are two Insha Fatima.
Yes,
Yes, ma'am.
ma'am.
Okay. So number
Ma'am, can
one,
I read
just a
Dhulia
moment.
Fatima?
Just now, who is reading?
Ma'am, Insia Fatima. I can first. Dhulia Fatima.
Dhulia Fatima. Okay, Dhulia Fatima, you will read this. Now, and
Okay.
later it will be followed by Insha Fatima Sabjani, right? Sabjani or Ravjani?
Ravjani,
Okay,
ma'am.
ma'am.
Ravjani. Okay. Fine, Insha Fatima, is it okay?
Ma'am, can I start
Yes.
it to read? While using a laboratory thermometer, the following precaution
Beta, no,
should.
no, you cannot. No, no, this is not the way to read. Sorry. Sorry, Beta. You're breaking everywhere. I want a continuity. Please practice, Beta. Yes, Insha Fatima.
Yes, ma'am.
Yes. Uh, Rabjani, Insha Fatima. Continue.
Yes, ma'am.
Read, Beta.
Okay, ma'am. While using a laboratory thermometer, the following precautions should be taken. Handle the thermometer with care. Do not hold the thermometer by the bulb while taking a reading. The thermometer should be kept upright, not titled.
Tilted.
The bulb
Tilted.
tilted. tilted. The bulb should not touch the surface of the container.
Whenever you're taking this laboratory thermometer, you should take care. First of all, the thermometer should be handled properly because it is made up of glass. Okay? So you have to be careful. Second, never touch the bulb which is having the mercury. Touch it from the glass, from the other end, while taking the reading. And third is you have to hold it vertically. It should not be tilted. It should not be on the side. And lastly, the bulb should not touch the sides of the container, not the bottom of the container. Is it clear? Is it clear?
Yes, ma'am.
How many girls are there in today's session? I am getting only one and two yeses. Do they know or don't they know? Hello, class.
Yes, ma'am.
But whatever I'm
Yes, ma'am.
teaching you people, it's only two or three people who are answering me. What about the rest of them? Are they sleeping? Or do they know everything? Or they don't know anything? See, these are the proposition that I'm giving you. You will only ask me, you will only ask me when I'm not. Okay.
खबर थी केस करें.
Ma'am?
Yes. Hello.
Yes, ma'am.
Yeah. I had to, like, I had some work, so I had to mute my mic. So, can you see my screen better?
Yes, ma'am.
Yes.
Here we are, right? This is what is your laboratory thermometer looks like. I think I've already given you the explanation how we should take care while using the laboratory thermometer. So we have done two thermometers. This is the first thermometer beta, clinical, and second is laboratory. Which one we are doing right now? Which one are we doing right now?
Digital thermometer.
Digital thermometer, right? Continue, beta. Sincere.
Okay, ma'am. Nowadays, digital thermometers are used to measure body temperature. They work on tiny dry cells. It is a safe device because it does not contain mercury, which is toxic substance.
So these they say this is the digital thermometer. You must have at your home, I think. This is commonly used by everybody. It's very safe. Why? Because it does not have mercury. We are using to measure body temperature, and we insert certain dry cells to let it work. Very safe because mercury is not present because we know mercury is poisonous. Yes, continue.
Digital thermometers. Digital electronic thermometers are preferred over
Conventional.
conventional conventional mercury thermometer.
Conventional.
Digital conventional
Yes.
mercury thermometer. Digital thermometers are easy to read because it gives LCD display of the thermometer of the person. They are
Temperature.
also of the
LCD
temperature
display
of
of the temperature.
okay. They are also mercury free.
Why are we using this? Why is it so convenient? It is convenient because it is even more convenient than clinical thermometer because it is easy to read and it has got LCD display. Now, this is called LCD display. You see this? This is the display, which is called as, and it is LCD display. So anybody can make out, anybody can read. You don't have to, squeeze or squint your eyes. You don't have to do that. It's easily read. So convenient, and moreover, they are not having any mercury. So these are the advantages of using digital thermometer. It's clear,
Yes, ma'am.
girls?
Yes.
What is the other name of digital thermometer, beta?
The resistance thermometer.
You understood the other name of digital thermometer is resistance thermometer, and you get in so many varieties. Can you see this over here? These are the varieties of thermometers. Clear? Different colors, different
Okay.
sizes. Now we come to a different topic altogether, which is known as transfer of heat. What it is called as? Transfer of heat. Anyone who wants to read better? I think Insha Fatima, you read three first lines, I think so. Happy?
Yes, ma'am.
Hello. Yeah. So who wants to read?
Ma'am, can I read Humaira
And Dolia
Sani?
Fatima? Dolia Fatima, where is she?
Yes, ma'am.
Yes, you need to practice a lot with her. I don't want any break in between. So, are you getting why I'm asking someone to continue? Because they are not breaking. It's a fluency. That is what first is what fluency I require. You will not break in between the words. Is clear, Beta?
Okay, ma'am.
Fatima? So I need to practice. I need you to practice today. Tomorrow I will ask you to do it again. Let's see how
Okay, ma'am.
you're improving. Okay? Till
Okay.
like keep on stopping. That means you have to keep on practicing and read it loudly in front of the mirror.
Okay, ma'am.
Yeah, who wants to read now?
Ma'am, can I read
Humaira
Nurani Safia?
Sani.
Ma'am, can
Nurani?
I do it?
Ma'am, can I read
Nurani
Sani?
Safia.
Sophia.
Yes, ma'am.
Yes, okay, Sophia, start.
Okay, ma'am. Transform of
It is
heart.
not transform. What are you reading?
Tran- transfer transfer of heart.
Heart. It is
Heart.
heart. Just a moment. Is it heart? Are we talking about heart or are we talking about heat?
Heat.
Then,
Sorry.
sorry, beta, sorry. No, this is not the way. You have to be very, very attentive, very, very particular. Yes. Please mute your mic. Who is next?
Ma'am, can
Can
I
I read to Aisha?
Maybe Aisha, I think you have already read.
ma'am can I read Sania?
Yes, give me your name first.
Sania Zaidi.
Sania Zadi. Okay, beta. Sania, start.
Transfer of heat. Heat flows from a body at a higher temperature to a body at a lower temperature. This is called transfer of heat. Heat is transferred in three different ways. They are number one, conduction; number two, convection; number three, radiation.
Good. Well tried. What's your name, beta? I forgot.
Sania Zaidi.
Sania. Practice still more, you can improve a lot. Okay, but you are a good reader. Good, good. Transfer of heat. So as we know that heat transfers from hot to cold. Is it clear? So from high temperature to low temperature. Now when it is moving from high to low, that is called as transfer of heat. What it is called, Vita? What it is called? Hello, can you hear me? Girls, can you hear me?
Yes.
Yes, ma'am.
Yes. Okay. So what is this called? Movement of heat from higher temperature to lower temperature is called as transfer of heat.
Heat.
Now, how the heat is transferred? First is conduction. First is conduction. What is conduction? Solid. Convection, liquid and gas. Radiation, gas. Is it clear? It's clear. So these are the media in which the transfer of energy or heat is taking place. Let's see over here. So from hot to cold, conduction. Hot to cold, convection. Hot to cold, radiation. Understood? Understood all of you?
Yes, ma'am.
Yes.
Yes.
So there are three ways the exchange of heat takes place. Now we are starting with conduction. Heat. You can continue.
Okay, ma'am.
Sophia,
Conduction. Conduction is the transfer
louder.
of
Adjust your
heat.
mic. Adjust your mic. Now start. Louder.
Okay. Conduction. Conduction is the transfer of heat from a hotter part to a colder part of an object due to the collision of its particles without actual movement of the particles from their position.
What is conduction? It's transfer of heat from hotter part to colder part. Right, beta? And why? Because hotter part has got particles. So particles got energy, starts colliding with the other particles. Again, it will start colliding with the other particles. And this is how the energy is moving from one particle to other particle. Why? Due to the collision. Is it clear? Is it clear?
Yes.
They are
Yes.
not moving, but they are colliding with it. They are not moving from the space because you know that in solid the particles are very close with each other. They are very close to each other. You know that. So how can this move from their position. They cannot. The only thing is that they collide, they vibrate, and they give the energy of themselves to the other particles, the nearby particles. And that's how the energy travels from one place to other place. Is it clear? And this is what. If you are heating at the one end, it is becoming red hot, and the heat gets transferred from hot to cold. Is it understandable? Hello.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is the same thing. The transfer of heat, you can see the arrow shows the transfer of heat from hot to cold. Right, beta? And this is what we observe in the kitchen. If we keep a spoon in the cooking vessel, so after some time, if we are absent-minded and we try to touch the spoon, we get burnt. Yes or no? So the heat exchange or the heat transfer from the cooking vessel to the spoon. Is it clear? It becomes hot. Yes or no? Hello? Hello?
Yes, ma'am.
Did you hear what I said? Did you hear what I said, Beta? Can you hear me properly?
Yes. Yes.
Now we will do conduction again with another activity. Let's start. Start, Beta.
Yes, ma'am. Conduction is a process by which heat is transferred in solids from the hotter end to the colder end. Activity: take an iron or aluminium rod or strip, fix a few wax piece- pieces on at equal distances, clamp the rod to a stand, hit the other end of the rod. The wax pieces
Rod.
begin.
Just a minute. What you are saying is this. If I'm not wrong. Am I right? Sophia, am I right? This is how you are pronouncing it? Yes or no?
Yes, ma'am.
Yes. Now, this is road and this is rod. Do you get the difference? Do you get the difference with the road and rod? The way you pronounce the meaning changes. Be careful. What you have to say right now is rod, not road. Okay?
Okay, ma'am. The wax, the
Wax.
wax,
Wax. Open your
the
mouth. Wax.
the wax pieces begin to melt and fall down from the heated
Fall
end.
down. It's not fall. Just fall
Fall
down.
fall down from the heated end. This shows that heat is transferred from the hotter end to the
Hotter.
hotter
Hotter.
and hotter and to the colder end by conduction.
So what activity we have taken, Vita? We have taken one aluminum rod or strip. Can you see this on here? This is aluminum rod. Okay? This is an aluminum rod or a strip. And this is a clamp. Can you see this clamp? This clamp. That means it is fixed at one position. And this is a stand. This is a stand. At one end we have a lighter, the gas burner. Right, Vita? What we have done, at equidistance we have put pieces of wax stuck to the iron rod. Right, Vita? Say something, then only I can proceed. Hello?
Yes, ma'am.
Hello?
Yes, ma'am.
Yes.
Yes, ma'am.
You understood this much? Equidistantly, we
Yes.
have put the wax pieces stuck to the iron rod. One end of the iron rod is heated up. So where does it go? The heat travels from the hot end to the cold end, right? Transfer of heat. The first, this will come down. Wax will melt and fall down, right, beta? Second, this will come down. Then this will come. Why? Because the heat is moving from, it is moving. It is moving onto the colder part. So whichever comes in on the way, that wax will melt and fall down. Right, beta? Hello?
Yes, ma'am.
Hello?
Yes, ma'am.
Yes? Okay.
Yes.
So this shows the movement of the heat. From where, beta? From the hot end to the cold end. So it is moving. Then it falls down. Again it moves. It falls down. Again it moves. It will fall down. All the wax will fall down. Right, beta? Is clear? So it shows that the heat is transferred from hot end to cold end by this activity. You want to ask me any question?
No, ma'am.
So what it shows, beta? Conduction of heat. What it is showing?
Conduction
Conduction
of
of heat. And where is it happening? Metal. Where is it happening, beta? Metal. Now you can see over here. This is red hot. Hot. And this is cold. Right, beta? So energy is transferred from hot to cold. More about conduction. Heat. Now you understand why I'm taking so many slides for one topic? Girls, you
yes,
understand why I'm taking so many slides? Did you understand or not?
yes.
To make things easy for you. Okay. Begin better. And if you can explain, well and good. Start. Start to read. Sophia.
Yes, ma'am. Conduction, transfer of heat through direct contact, occurs anytime objects at different temperatures are touching each other. As long as the objects are in contact, transfer of heat will continue until the temperature of the objects is the same. Example: if you leave a metal spoon in a pan of soap that you are heating on the stove, it may burn your fingers.
Yeah, it is soup, not soap.
Soup that you are heating on the stove, it may burn your fingers. The spoon is in direct contact with the hot soup and heat is transferred to the spoon.
More about conduction. Direct contact. Now you can see over here, this is a hot spoon soup. And here, this is hot. And this is cold. What is that cold? Spoon. After some time, when you touch this, you will find it hot. Right, Vika? So this is exchange of heat. Any problem? Am I right or not? Hello?
Yes, ma'am.
Yes, ma'am.
Right. Now, let me this is the direct contact. For transfer of heat, what is must? Different temperature. One has to be hot and the other has to be cold. Then only there will be transfer. When the objects are in contact, transfer of the heat will continue. Am I right? So contact is a must for the transfer of heat. For example, you have taken a metal spoon. This is a metal spoon, right? And you have kept it in a soup, which is being heated on the stove. If you try to touch this handle of the metal spoon, you will burn. Why? Because soup is in direct contact with the soup and the heat has got transferred from the soup to the spoon. And the spoon got hot and if you touch it, you will get burnt. Is it clear?
Yes, ma'am.
Clear? This is called conduction. What is better? Conduction. Now, according to conduction, what are conductors and insulators? Read it. It will take only 1 minute. Read it. I said read it better.
Yes, ma'am. Conductors and
Ma'am,
insulators.
I know it will take 1 minute. Read.
Conductors are materials which allow heat to pass through them easily. Iron, aluminum, copper,
Upward.
etc. Insulators are materials which do not allow heat to pass through them easily. Wood, plastic, glass, rubber, air, water, etc.
What is conductor? The materials which allow the heat to pass through. All the metals. Insulators which stops. So what does it mean? Allows heat, do not allow heat. So insulators are bad conductors. What are they? They are non-metals. What are non-metals? Wood, plastic, glass, rubber, air, water. Is it understandable? Please go through the uploaded video without fail. Okay? That is your homework.
okay, ma'am.
Okay, beta? That is your homework.
Okay.
And get
Okay,
ready
ma'am.
for the examination. Thank you. Bye.
Ma'am,
Bye,
I
ma'am.
have to write anything?
No, beta. You just go through the uploaded video. That's it. No writing. You have to just learn.
Okay, okay, ma'am.
Okay,
Bye.
ma'am.